Okay, so we're looking at what it means to find the determinant of a matrix, okay? So let's get right into where it says 2 by 2 determinants. And we're going to say that every square matrix has a number associated with it called its determinant. Now, what do we mean by square matrix? Rows and columns are equal, right? Rows and columns are equal, okay? Now, there's a couple notations that you can use to represent the determinant of a matrix, okay? So if I'm working with matrix A, I could put a DET in front of it. That means determinant of A. Or you put the A in what looks like absolute value bars. That means determinant as well. Okay? All right, so it's really easy to find a second order determinant. A second order determinant would be for a 2 by 2 matrix, okay? So notice the notation down here. Rather than the brackets that we typically use for the matrix, see how I got the straight lines? That's an indication that I want to find the determinant of the corresponding matrix, okay? So here's a formula to do it. I take the product of A and D, I subtract it by the product of B and C. So we're taking those two numbers multiplied together, subtracted by those two numbers multiplied together. And the result is simply going to be a numerical value. Okay? All right, so example 1, find the value of each determinant. 7 times 2 subtracted by 4 times negative 3. That's going to be 14 subtracted by negative 12, which is 26. That is my determinant. Notice I'm doing similar calculations to matrix multiplication, but the one difference is there's subtraction here rather than addition. Okay? All right, next one, notice I'm just using the other notation here. I still have the brackets around the matrix, but I put the DET in front of it to say I want the determinant. Calculations are the same though. 6 times 0 subtracted by 4 times negative 1. That's going to give me 0 subtracted by negative 4, which is, of course, 4. All right, so try practice 1 real quick. All right, Maggie, what'd you come up with? Negative 23. So you probably did negative 15 subtracted by 8 to get to that negative 23, right? Any questions on a 2 by 2 determinant? All right. So now let's move to a third order determinant, or determinant for a 3 by 3 matrix, okay? So there's a couple different ways you can do this. I'm going to teach you how to do it with a method called expansion by minors, okay? So that requires us to know what a minor is. A minor of an element is the determinant formed by deleting the row and column the element is in. Okay? Was that your ringtone?
Yeah.
Oh my goodness.
I never have my ringer on. I don't know how it got on.
I felt like we were like at a rave or something. Boy, I need some glow sticks. Okay. All right. So again, a minor. Each one of the elements of this 3x3 matrix has its own minor. Okay. So if I want the minor of matrix, or I'm sorry, of element A, all I'd have to do is delete that row and that column, and I'd be left with E, F, H, and I. Okay, those four elements would give me the elements I need for Mr. Widow. Now he's trying to share a photo. Don't open it, people. Don't fall for that. Okay, so notice the minor is known as the determinant formed by deleting the row and the column, okay? So here's how we can use expansion by minors for this 3x3. Here would be a possible setup. You're going to take that first element of matrix A, and you're going to multiply it by its minor, which would be E, F, H, I. And notice the notation here. I've got the straight lines to represent that that is a determinant. Okay? Then we're going to do subtraction to follow that with element B multiplied by its minor. So the minor of element B, I'd get rid of the first row and the second column, and that would give me elements D, F, G, I. Everybody good with that? Follow that up with a plus sign, and then I'm going to use element C multiplied by its minor. Now the minor for C would come from deleting first row, third column. You'd be left with D, E, G, H. So what this does is it takes the 3x3 determinant and it rewrites it in terms of 2x2 determinants. And we've just seen finding a 2x2 determinant is pretty simple, right? Okay. So let's actually put some numbers in for each of those letters. Evaluate using expansion by minors using the first row elements. So here's the setup. 1 multiplied by its minor. So get rid of that row, that column. It's going to give you -1, 3, -2, -3. Subtracted by 0 times its minor. So I'm going to delete the first row and the second column. That's going to give me 2, 3, 4, -3. Plus -1 times its minor. So get rid of the first row, third column. That leaves you with 2, -1, 4, -2. Question so far? Yes?
When do you know if it's like minus or addition? Is it always going to be just the...
Hold that thought. Hold that thought. Okay? Once we do the next example, I think that'll really solidify that. Okay, so now I have to find the 3 determinants next before I do that multiplication between the number that's out in front of each of them, okay? So I like to just kind of set it up like this. Plus -1 is really -1, right? Okay, so to get that first determinant, I'm simply doing -1 times -3, which is 3. subtracted by -6. That gives me +9, right? To get the next one, I'm doing -6 subtracted by 12. That's -18. And then to get the last one, -4 subtracted by -4. That gives me 0. Oh, that one works out so nicely. 1 times 9 is 9. 0 times -18 would be 0. So this is -0. And then minus another 0. Determinant is 9. Any questions on that? Okay, so now let's move to the next one. Notice it's the same matrix elements, but my directions have changed a little bit. It says now evaluate using expansion by minors and the second column elements. The second column elements, okay? So there's several different ways this can be done. I've only shown you so far how to do it with the first row elements, okay? So think of it like this. When we use the first row elements, we took the positive of that first element, then we did the negative of the second element, and then the positive of the third element, right? If I skip to the second row, it's going to be the opposite. It's going to be minus, plus, minus. And if I do the third row, it's going to be plus, minus, plus again. So that layout right there tells me what sign I should put on each element of any row or any column. All right. So if I want to use expansion by minors with the second column elements, I'm focused on those signs. Okay. And here would be the setup. I would take the element of 0, so that's the top element of the second column, right? And I would take the negative of that, okay? Which is still 0, right? But if it were anything other than 0, we would take the negative of it, okay? Now you multiply it by its minor. So what is the minor of 0 here? 2, 3, 4, -3. Then I would do plus. What element would I use next? What do you think? -1. So I'm just moving to the middle element of the second column, right? And I'm going to multiply it by its minor. So I delete the second column and the second row. And that leaves me with 1, -1, 4, -3. And then what sign would I use next? Minus. And what element? -2 multiplied by its minor. So I get rid of the second column and the third row. That leaves me with 1, -1, 2, 3. Okay, now let's see. We should get the same result theoretically as the previous procedure, okay? So I'm going to do -6 subtracted by 12. That's -18. I'm going to do -3 subtracted by -4, which is what? 1. And then I'm going to do 3 subtracted by -2, which is 5. I wind up with 0 minus 1 plus 10, which is 9. Same answer as before. If I asked you to do it with like the third row, think you could?
Good afternoon, everyone. Before you all leave for this nice extended break, we wanted to